Okay, guys, this is going to be our next section over area, and this is area of circles and then parts of a circle. You did a little bit of this in middle school, probably just finding the area of a circle. Then, so the new part for this high school level is going to be finding parts of a circle, and you'll see what I mean here on this next slide. So we're just going to get straight to it. We're going to recall what a circumference formula is. So circumference is the length around the circle. So if you have a circle and you're finding the length from there to there, then that means all you have to do is take pi and you times it by the diameter. That's one. Or the other formula you might be familiar with is 2 times pi times the radius. Okay, and again, you did this in middle school, so I'm just kind of refreshing your memory. The area of a circle is going to be pi r squared. So the main difference that we're not going to do in middle school is you're not going to use 3.14 for pi. You're going to use pi in the calculator, which if you turn your iPhone sideways, you can see the pi symbol. And sometimes we might leave our answer in terms of pi. So the new stuff that you'll be doing at the high school level is finding the area of a sector of a circle. So what is a sector of a circle? It is the region between two radii, that's plural for radius, and an arc. Okay, and so we'll draw that in the picture right here. So 2 radii. So here's one radius, here's the other radius, and here's the arc. Okay, and so all we have to do is just shade that in. And that is the region that we're going to find the area of, that part right there. Okay, and so how do you find the area of that? Here's what you want to do. You want to take a portion of the circle, okay? And so the whole entire circle is 360 degrees. So if I only want a portion of the circle, that means I'm going to take this angle right here, okay, which is also the same as this arc. That's going to be X amount of degrees. X amount of degrees. So let's put a little degree symbol right there. So whatever that angle is, which that's a central angle, and if you think back to earlier this school year, when we did a review of circles, that's a central angle, and that has a certain degree. Well, that's going to have the same as the arc, okay? So whatever that angle is, or whatever that arc measure is, they're going to both be the same. You're going to put that over 360 degrees, and then times it by pi r squared, which pi r squared is the area of a circle. Okay, we'll practice using this here in a second. Let's go to the next part of a circle. This one's called a segment of a circle. So a segment of a circle is, not sure what happened there. This is the region between a chord and an arc. Okay, so the region between a chord and an arc. So where's the chord? If you forgot way back from chapter 1, and you have these notes in your notebook from way back in chapter 1, this is a chord. This is a segment that goes from, or has its endpoints on the circle. And then here's the arc. So I could find the area of this one right here. Now the whole other side is technically a segment as well, because that would still be bounded by an arc and a chord, okay? But most of the time they'll have it shaded. Okay, so we're just going to focus on the pink region. And so what is that formula? It's going to look like this. X over 360. Okay, remember those are in degrees. So I'm going to put a little degree symbol there. And times pi r squared. And then this is the new part, because this is what should look familiar from the segment of a circle earlier. This is new right here, where it's base times height divided by 2. So what does that sound like? That is the area of a triangle. So you're probably saying, where do we get this triangle from? So I'm going to draw the center of a circle, and I'm going to draw this radius and this radius. So this region right here, let me get this blue part out of here. So this whole region that I just highlighted in blue, from here to here to here, that's a sector, okay? That is a sector that looks exactly like the one that I just showed you up here, right there. And so if I find the area of that whole sector, well, I have to get rid of this part right here that I just put a star in. Well, what's the shape of that white section? That's a triangle. So I'm going to highlight this triangle in red. And so we have to subtract, you'll notice right there, there's the subtraction sign. We have to subtract that red triangle in order to give us just the area of that shaded pink section. And so that's how you find the area of a segment. We'll do 2 examples of this because most kids tend to have a hard time doing this area. Okay, let's go to the next one. This one's a little easier. This is called an annulus. Okay. So a good definition for that would be the region, keep it the same, between 2 concentric circles. Okay, and so you're probably wondering what concentric circles are. These are 2 circles that have the same center. So this center right here that I just kind of circled in blue, that's the center. Those 2 circles have that same center. Okay, now it's the region between the 2 of them. So I'm going to get my highlighter. I'm going to highlight the region in between. So that's all of this part right here. So it ends up looking pretty much kind of like a donut, okay, or a tire of some sort, okay? So that area that's shaded in green is what you call an annulus. And so how do you find the area of that right there? Well, it's just basically finding the area of 2 circles. So this red segment right here is represented by big R. That's the radius of the big circle. This little section right here that I'm about to highlight in blue, or that radius, I should say, that's the radius of the small circle. And so all you have to do is take the big circle and minus the small circle, and that'll leave you the area of that green shaded section. And that's how you find the area of an annulus. All right, and then one last part that pertains to circumference, actually. So we're going to do a little bit of circumference, is finding the length of an arc. Okay, so how do you find the length of an arc? This is going to be the distance, since we're talking about length, the distance between 2 points on the circle. So it's the distance between 2 points on the circle. So if I put a point right here on the circle, and I'll put a point right here, and I want to find the length of that part right there, this is what you're about to do. So how do you find the length all the way around the circle? You use the circumference formula. So what do you think you do to find the length of just that arc? Kind of what you do to find the area of a sector. You're going to use that x over 360 fraction, okay? Because we're going to find only a portion. So whatever that arc is in degrees, because arcs can be measured in degrees, or if you connect those endpoints, whatever that angle is in degrees, that's what you're going to put in the formula, x degrees over 360 times pi times diameter. So remember, that is your circumference formula. And you don't have to memorize any of these formulas. You can have them all right there in front of you on your notes sheet. And you have them on your formula chart as well. Okay, so these are all the formulas that we're about to work with, okay? So we're gonna work with circumference, we're gonna work with area, work with sector, the area of a sector, the area of a segment, the area of an annulus, and the length of an arc, okay? All right, let's practice that on some problems. So over here on this first problem, we have that sector shaded in pink, and we need to find the area of that shaded region. So I'm going to use my formula. And so we have to figure out what this angle is right here in degrees. So we do know that from here to here is 240 degrees. So if we subtract 240 from 360, that leaves us with 120 degrees. Okay, so this is a 120 degree arc out here. So we're going to put that onto our formula, 120 over 360 times pi r squared, and r is 8. Okay, I'm going to reduce this fraction right here, which I know 120 is 1/3, and then I know 8 squared is 64, and then I'm going to move the pi out in front. So what is 1/3 of 64? 3 goes into 64, 21 and 1/3 pi. So 21 and 1/3 pi. This is right here, leaving our answer in terms of pi. 21 and 1/3. You could also use the decimal if you want. So 21.33 pi. But of course, leaving it in fraction form is more accurate. So 21.33 pi. And they didn't give us a unit, so we're just going to say units squared because we're finding area. Okay, so now it says find the length of arc JH. Okay, so that would be the minor arc right here. We don't want to find the big blue arc over here because that's a major arc. Okay, so when you list it with just 2 letters, that's a minor arc. So we're kind of going to do that the similar way. We're going to take 120 degrees over 360 times pi times diameter, which is the circumference formula, because we're finding length, okay? Oops, I just made a mistake. That's the radius, right? So we're not going to put 8. We're going to put 16. Okay, so pi times diameter. Okay, so this we already know reduces to 1/3 times 16 times pi. What's 1/3 of 16? 5 and 1/3 pi. Okay, and this is unit squared. So this is the, oh, not unit squared, just units, because we're doing length. So 5 and 1/3 pi units. Okay, so I like leaving my answer in terms of pi. If you want to multiply it out and put the decimal in, you can do that as well. All right, let's go to this next one. This next problem is finding the area of the shaded region. So that's the area of a segment. So I'm going to highlight this from there to there. That's the area of a segment. So what is this angle right here measure? That's 90 degrees, which is the same as its arc. So I'm going to put 90 over 360, which a lot of y'all know that that's already 1/4, right? So if you want to, you can also just go straight to writing 1/4 times pi r squared. Okay, I'm just using the formula from the other page. And then I have to minus the triangle. So how do you find the area of the triangle? Well, remember, these are radii, so that means this piece is 7 right here. So the base and the height of this triangle, because that's a right angle, is 7 times 7 divided by 2. Okay, so here's the area of the sector minus the triangle will leave us with just that blue shaded region right there. Let me get this red Okay, so now let's start simplifying. We have 1/4 times 49, because that's what 7 squared is, times pi, minus 49 divided by 2, which is 24.5. 49 divided by 4, or 1/4 of 49, is 12.25 pi minus 24.5. So if I said to leave your answer in terms of pi, you would actually stop right there. And this is units squared. Okay? So you could do that, or if you put that whole thing in your calculator, 12.25 pi minus 24.5, you get roughly, and this is going to be an estimate, 13.984 units squared. Okay, so you can put your answer in decimal like this, or you can leave it like that below. Okay, next thing, how do you find the length? So there's practicing finding length again. So if this is 90, it says find the length, and I'm going to use my green pen to find the length of arc JHS. So here's J to H to S. That's that arc right there. So we're going to do that like we did over here on the left. What is the length of that green arc? 270, because this piece over here is 90, which you should know is 3/4. So we're going to take 3/4 times pi times diameter, which the diameter is 14. So what's 3/4 of 14? 3/4 times 14 times pi. And if I put that in my calculator, that's about 10.5 pi. Okay, so that's the length of the green arc JHS, 10.5 pi. And this is just in units, because this is length. All right, let's go down here. Let's do 2 more problems with areas of circles. Down here it says find the area of the annulus. So the annulus is this section, all right in here. And all of that. So we're going to find the area of the big circle and minus the area of the small circle. So big pi r squared minus little pi r squared. So the big R would be 5, because I'm going to take half of that 10. And the little r you see is 2. So this is 25 pi minus 4 pi. These are like terms, so you can subtract them. And it ends up equaling 21 pi. So I'm just going to leave my answer in terms of pi. So these are pretty easy. 21 pi units squared. Let's try one more hard one. This one is area of a segment. So I put 2 examples of segments because, like I said, and students in the past have a hard time finding the areas of those segments. So let's practice this one more time. So remember the process. You want to find the area of this sector, and then you want to subtract the area of this triangle, and then that will leave us with the area of the green shaded part, which is the area of a segment. So I have to take the area of the sector. Well, I don't know the radius. So how am I going to find this radius? I have to focus on what that triangle looks like. This is 20 inches. This is 120 degrees. And you should know that this is equal to this because those are both radii. So if that's 120 degrees, I can drop an altitude here, which makes this 60, y'all. So if that's 60, that makes this 30. This half right here is 10, and this half is 10. So this right here is the short leg. And you can do trig to figure it out. And so that would be tangent. So I can do tangent of 60 degrees equals 10 over, I'm going to use h because this is my height of the triangle. Okay, and it'll be a decimal, and that's okay. So let me do the trig real quick because I haven't done this yet. So I'm going to do 10 divided by tangent of 60 equals that. So the height of this triangle is 5.7735. Okay, you don't have to round that far out, but I do. Okay, I like to round more. And so that right there is the height of this triangle. So now I know the base of the triangle, and now I know the height, so I can use that. So I can use that to in the formula. So we're going to do x over 360, so 120 over 360 times pi. I need the radius now. I forgot. That's the main thing why I'm solving this. Okay, so this is the height, which was 5.7735. Now I'm going to use that to find the hypotenuse, which is that. So I'm going to do Pythagorean theorem real quick. And then so I'm using Pythagorean theorem. I'm going to do 5.75 squared plus 10 squared equals c squared. Okay, so I just realized I need the radius. And so the radius, or this length right here of this triangle, is 11.55. Okay, so the radius is 11.55. And again, that's just an estimate. So 11.55 squared. And then I have to minus the area of the triangle. So remember, the area of the triangle is base times height, which the height is 5.7735 divided by 2. Okay, sorry, it's all squished in there. So this reduces to 1/3, because 120 of 360 is 1/3. I'm going to square 11.55. Which is roughly about 133.4 pi minus, now I'm going to find the area of the triangle, 20 times 5.7735 divided by 2. So the area of the triangle is roughly 57.735. Okay, I'm almost there. 1/3 of 133.4, so I'm going to put 133.4 divided by 3, which is 44.4667, repeating, so I'll just do 467 pi minus 57.735. So if I wanted you to leave, oops, this in terms of pi, that's what you would have right there. Okay, let me highlight it for you right here. Oh my goodness. So that's right there, your answer in terms of pi. Okay, but if I wanted you to have just a decimal to the 10th place or hundredths, whatever I may say, I'm just going to round to whatever right now. We're going to do 44.667, repeating, times pi in the calculator, like using pi in the calculator, minus 57.735 equals, so the area of the shaded region is roughly 81.961. Okay, if I'm rounding to the thousandths. And this is inches squared. Okay, like I said, you can have that in decimal, or if I said to leave it in terms of pi, that's what it would be right there. Okay, so we had to use trig and Pythagorean theorem to figure out the height right here. Let me use my highlighter to highlight it in pink. We have to find this right here, and we had to find the radius in order to put that into our formula there, and in order to find the height of the triangle. So you have to use your trigonometry still. That doesn't go away. And that is it.